Good morning or evening everyone, whenever you watch this video. First of all, thank you for willingness to watching our presentation. We are from the Informatics Engineering and today our team will present a result of analysis of journal entitled Automatic Data Retention, a Standardized Database Architecture for PT Telkomsigma. My name is MySQL and together with my teammates Muhammad Sofyan Maulana, Satrio Erlangga, and Muhammad Rizal Uzaki. We will explain how database retention process can be transformed from manual operation into an automated and standardized system. Let me begin with slide 2. Okay. These slides show the main problem faced by many organizations today as data continues to grow exponentially. Database performance gradually decreases. Large amount of inactive data remain stored in operational database, making systems slower and harder to maintain. There are three major issues. First, the retention process is separated from operational data management, creating inefficiencies. Second, organization often rely on manual retention activities, which consume a lot of time and increase the risk of human error. Third, there is standardized architecture for managing database retention across the organization. This challenge creates a significant bottleneck and reduces overall system performance. Now let's move to slide 3. This slide illustrates the development process of the proposed solution. The first step is data inventory, where existing retention parameters are analyzed. The second step is resource estimation and scheduling, which determines the required resources and implementation timeline. The third stage is designing system architecture using standardized retention script. The fourth stage is coding the web UI and stored procedures that automate retention activities. Finally, the fifth stage is full implementation and testing within the Telkomsigma environment. This structure process ensures that the solution is scalable, reliable, and easy to maintain. Thank you. I will now hand over the presentation to Satrio Erlangga.
Thank you all. Now I will explain the analysis of existing retention process and the opportunities for improvement. Let's start with slide 4. This slide presents a SQL analysis of the current database retention workflow. In terms of weakness, the process heavily depends on manual execution and database administration. This creates inefficiency and increases operation risks. The main change is the possibility of human error during retention activities, which may affect data consistency and system reliability. However, there are also strengths. The organizer already has a strong technical foundation and experienced personnel who understand database management. The biggest opportunity is automation. By implementing standardized script and automated scheduling, the organization can improve efficiency, reduce error, and simplify operation. Now let's move slide 5. This slide compare the industry standard. Apabila for data retention, a prelude is suitable for large scale policy management but requires a more complex infrastructure. Cron jobs are commonly used for scheduling tasks, but mainly focus on timing and do not provide comprehensive database retention functionality. Application and MySQL are useful for backup purpose but do not directly address active retention management. After evaluating this option, the strategy is the use of stored producer. Stored producer allow retention process to run directly within the database server. The upload reduce network latency, improve execution efficiency, and support archive standardization. For the reason, stored production were chosen as the core technology of the proposed solution. Thank you. Next, Muhammad Sofian Maulana will explain the system architecture and implementation.
Thank you, Satrio. Now I will explain the proportion architecture and how the system operates. Let's begin with slide 6. This slide presents a three-tier automated architecture. The first layer, web configuration UI. This interface allow administrator to define retention rulers and parameter with or directly modifying database code. The second layer, shell script. It as automated scheduler and communication bridge between the user interface and the database system. The third layer, stored procedure. This is the acquisition engine where retention activities are processed directly inside the database in production. Together, the three layers create a flexible and maintainable architecture for automated data retention. Now let's move to slide 7. Okay, this slide demonstrates how the system works in practice. Administrator manages retention policy through the configuration list interface. The system then records all activities in the host DB, providing transparency and traceability. Once configuration, retention tasks are executed automatically according to predefined rules. As a result, database administration no longer need to perform repetitive manual tasks. The system ensures consistency, reduces operational workload, and improves monitoring capabilities. Thank you for your attention. I will now pass the presentation to Muhammad Rijal Mujaki for the final section.
Thank you, Sufyan. I will conclude your presentation by discussing the impact and benefits of the proposed solution. Let's start with slide 8. This slide compares the legacy workflow with the automated workflow. In the legacy process, database retention depends on multiple manual steps, distribution, and scripts, and administrator intervention. This makes the process fragmented and inefficient. In contrast, the automated workflow uses predicate parameters, automated cell scripts, and stored procedures to execute retention tasks. The result in a standardized, centralized, and automated process that significantly improves operational efficiency. Now let's move to the final slide. This slide summarizes the key benefits of the solution. First, it eliminates manual database retention activities, reducing the dependence of human intervention. Second, it enables zero-touch execution, meaning retention and archiving process can run automatically with minimal supervision. Third, it supports sustainable organizational performance by improving database efficiency, reliability, and scalability. In conclusion, the proposed architecture transforms database from a manual operation task into a standardized and automated infrastructure that supports long-term business growth. Thank you for attention. We will be happy to answer any question.